Hello students, today I am going to deliver a lecture on the topic of join in SQL. In that lecture, I will explain the concept of join and their types, there are several types, and how to implement the join operations in SQL. As we all know, the join operation actually joins the two tables, the tuples of two different tables. Okay. So here, uh, the tuples of a one table make a pair with tuples of another table. Okay. So here always we provide some condition for making a pair. Okay, and those tuples that satisfy the condition uh, make pairs and join uh, each other in a single in a single and join each other and will make a new tuple that will have values of both tuples. Okay, so this is how we join to do two different tables. So here join are of two types. Basically it is classified into inner and the outer join. In inner join, uh, those tuples which satisfy the conditions make pairs, and only that tuples will come in a resultant table. Okay. So in inner join, only those tuples that make pairs and those satisfy the conditions for that satisfy the pairing condition will come in the resultant table. Whereas in the outer join, uh, those tuples that doesn't make pairs and doesn't satisfy the pairing condition can also come in the resultant table. So here outer join are further is further classified into three categories: the left, right, and the full outer join. In left outer join, as you can see here, the table 1 and table 2, to apply left outer join, we will write only the left. We can write it as left join. So in that case, those tuples that make pairs will come in the resultant table, and the tuples of the left table that doesn't make pair will also come in the resultant table. Whereas in the case of right join, or can say the right outer join, the tuples that make pairs will come in the resultant table, and the tuples of the right table that doesn't make any pair will also come in the resultant table. Whereas in the full outer join, the tuples that make pairs will come in the resultant table, and the tuples of both table that doesn't make pair will also come in the resultant table. So let's see one by one every case. So as you can see here, we have two different tables: student name and the student stream, the table 1 and the table 2. So here I am going to apply the inner join over these two tables. So here the tuple of student name will make pair with the tuples of student stream with only those tuples which is having the same value of the common attribute. So first of all, the common attribute is ID. So we will, so here the condition for the pairing is that the common attribute value must be same in both tuples of two different tables. So here one stack is can make a pair with one CS because the ID is same. One stack can make a pair with the one IT. Here two Alex can make a pair with two EC. Here three Samir cannot make a pair with any of the tuple of the table student stream because none of the tuple is having ID 3. Similarly, 4 Rick will not make a pair because the ID 4 is not present in any tuple of a student stream. So as I've said, in inner join, only those tuples that make pairs will join each other and make a single tuple in a resultant table. So you can see here one side CS, one side IT, 2LX ECE will come in the output. To implement the inner join in SQL, we will have to first write the attribute name, what we want in the output. Since we are using the multiple tables, that is why we have to write the name of a table along with the attribute name. So as you can see here, I have written as1.id. Here as1 is the table name, the first table as1.id, as1.name, that table name as1, and attribute name is name. Okay. So here as2.stream, table name is s2 and attribute name is stream. Okay. So first of all, we will select the attributes. Then from, we will use the keyword from. As we all know in SQL, after the from keyword, we write a name of a table from where we we use the attributes, from where we will select the attributes. Since here multiple tables are there, so after from we will make a join. We will apply the join between the multiple tables. So you can see here I'm going to apply inner join between two tables, the student name and the student stream. Okay. Just after the form, we will apply the join between the two tables. So to apply the inner join, we will just simply write the inner join. Okay. The table name, since the student name is a bigger name, so we can abbreviate it as S1. So to make abbreviation, we have to write it as. So I have written here student name as S1. Okay, I have given a name, different name to a student name, and similarly the student stream is now become S2. Okay. So I have done the inner join, but one thing is still missing, that the condition for the pairing. So we will use the keyword on to provide a condition. So condition for the pairing here is the common attribute value must be the same. So common attribute here is ID. So I have written here as1.id must be equal to the s2.id. So that query will return the ID name and the stream from both tables, uh, and the same output we will get as I have obtained here in the resultant table. Now here I have a query that the name of a stream of student ID2. Here I have a query that I want the name of a stream of a student having IDs 2. So first of all, we will select the attribute stream. Since the attribute stream is present in the table 2, so I have to mention the table name. So I have written here as s2.stream because the student stream I have given a name as 2. Okay. So then I will write from. After from, as we all know, we write a table name. Since we have two different tables, so we will apply a join here. Here I'm going to apply inner join. So inner join between the student name and the student stream. Okay. And definitely here the condition for the pairing will be the common attribute value must be the same here. So I have written the as1.id is equal to s2.id. Okay. Now I have obtained that resultant table. The below table we can obtain by writing that code, but still one thing is missing because we want the name. Sorry, sorry. Oh, okay. That table we will get by writing that code, but still one thing is missing to get the name of student ID2. we need to select the tuples having id 2. Okay, so here I have written where s1 dot id is equal to 2. So only that tuple which is having id 2 will be selected, and the stream will become the stream given in that tuple will become the output. Okay. In the alternate way, we can write it as you can see the below given query. This is the alternate way of writing the same query, and output will be the same, but the way of writing is different. Or also we can say the writing the second query is an optimized. It is an optimized version, because here I have selected the tuples having id 2 from the first table, and then I have done a inner join, then I have applied inner join with the student stream, and condition will be the same. The s1 dot id is equal to the s2 dot id. So here this is the optimized way, because if I select the tuple having id 2 from the student name table and then make a join with the student stream, then we have to perform only 4 match operations. Okay, and after join we get only single tuple, and from that tuple we can select the stream attribute, the name attribute, sorry, stream attribute, right? But if we don't if we make a inner join between table 1 and table 2 directly, as we did in the first query, then we need to perform 16 match operations, so it is not a time efficient. Okay, and after getting the resultant table, we have selected that tuple having id 2, and from that tuple we have selected the stream attribute for the output. Okay, so this is not a optimized. Okay, so we can write every query in a multiple ways, but some queries are optimized and some are not. So we always try to write in a way that is having the less time complexity. So that's okay. Also we can join the 3 tables. What we do here, first we will join 2 tables. Okay, and that 2 tables will return a resultant table. Let's say 1 and 2 is my two different table, and the resultant table is r1. Okay, and then we will make another join with the third table, and then we will get another resultant table, the rp. So this is how we join the more than 2 tables in a single command, in a single query. Sorry. I have an example for the joining the more than 2 tables. Let's say if I want the name of students having enrollment in subject DSA and the DBMS, and what we will do first, we will get the tuples from the course table which is having the DSA and DBMS, and these tuples we will make a join with the student course table on the basis of condition that the course ID must be same, because the course ID is the common attribute here. So we will get in the resultant table, we get the tuples having student ID as a 1, 2, and the 4, right? And after getting that resultant table, we will make an inner join. We will apply inner join between the student and the resultant table, and then we will get those student names in the resultant table, final resultant table, which are having the student ID S1, S2, S4, or can say the having the course ID DSA and the DBMS. So this is the example for joining the more than two tables using the inner join. Let's see the outer join. Uh, for the, as I've discussed, that an outer join, the tuple doesn't satisfy the condition, can also come in the output. Okay, and I've also said that it is out of outer join out of three types: the left, right, and the full outer join. In the left join, to apply the left join, we have to just write the left join here. Okay, and you can see in the left join, those tuples that make the pair will come in the output, as you can see, 1xcs, 2lxit, and the 2lxec is in the output. But here 3 Samir and 4 Rick also will come in the output, because it is these tuples belongs to the left table and doesn't making pair. And as we all know, in left join, the tuples that doesn't make pair and belongs to the left table will also come in the output. But corresponding to the Samir and Rick, the string value will be null, because there is no tuple in the right table corresponding to the Samir and the Rick. Similarly, in the right outer join, to apply the right outer join, we have to just write the right join. Okay, and you can see here the tuple from the right table that doesn't make pair will come in the output, but the tuples of the left table that doesn't make pair will not come in the output. And at the last, the full outer join, in which the all tuples that doesn't make pair will come in the output. You can see here the 3 semi 4 Rick is present in that output table, and 9 EC also in the output table. But corresponding to the Samir and the Rick, the string value will be null, and corresponding to the 9 EC, the name will be the null. Next is the cross join. The cross join is to apply the cross product between the tuples of two different tables. That actually the output will return the every possible pair of the tuples of two different tables. You can see here the one table is having the tuple 1, 2, 3, and another table is having the tuple ABC. So if we apply the cross join, then we will get the 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C. So all possible combination. At the last is the semi and the anti join. In the semi join, we just get only those tuples that make pair, but the tuples of one only of the left table. As you can see here, one SIAC is making pair with one CS, but the tuple of only the left table will come in the output. Means the one SIAC will come in the output, but one CS will not come in the output. And 2LX is making pair with 2 ECE. So here only 2LX will come in the output, because it belongs to the left table. Only the output of single table will come in the output, and the tuple must have some pair. Whereas in the anti-join, as you can see in the right side of that slide, in the anti-join, we will select only those tuples that doesn't make pair, and the tuple must be of only the single table, or cancel only of the left table. So here the 3 semi and 4 Rick are those tuples that is not making any pair and belongs to the left table, so it will come in the output. this is the integer. So that's all for the today's session, and the next session we will discuss the indexing scheme and the triggers. Thank you.